Hi, my name is Ayer Kornblit, co-founder and CEO of ParagonH2, which is working to reduce the financial and environmental costs of cleaning water. Why are these costs so high? Because it takes a lot of electricity, polluting electricity, to clean water for homes, factories, and cities around the world. ParagonH2 will tackle both the financial and environmental aspects by providing a device that doesn't use electricity but uses hydrogen to clean water, and it actually produces electricity at the same time. So let's make a deal. ParagonH2 will give you a device that cleans water using the hydrogen you already have on site. You are, for example, a desalination plant that has hydrogen or a chemical plant. All we ask in return is that you provide us with €0.75 for every 1,000 liters that you clean using our device. The water market is over €150 billion per year and growing. But let's focus in on the near term. It's important to us. Desalination and industrial wastewater, which is already larger than €20 billion per year and growing. Finally, the area we're really going to start off in our beachhead market, over €800 million per year and growing, consisting of existing hydrogen users that need to clean their water, such as methanol manufacturers, petroleum refineries, and ammonia manufacturers. The value we give our customers is great. For every 1,000 liters that they clean, they save about 13 kilowatt hours of electricity, 3.5 kilograms of carbon emissions, they get their clean water, and they save around €1.50 of operational expenses. Even after paying us in the petroleum example, ParagonH2 will save them about €600,000 per year as compared to reverse osmosis technology and 10.4 million kilowatt hours of polluting electricity. The technology is essentially a hybridization of fuel cells and electrodialysis. We feed fuel cells hydrogen and air, they produce electricity. Electrodialysis uses a voltage to remove pollutants that are dissolved in the water by pulling them out, such as salt and phosphates. You have a single device that can do both. Feed it dirty water and hydrogen, and what comes out is clean water and electricity. This is a picture of a prototype already running at the Technion, desalinating, producing electricity, which has been developed by my co-founder for the last 2 years, and the Technion has filed a patent with him listed as a co-inventor. It generates electricity while cleaning water. It has improved maintenance as compared to reverse osmosis, can reduce costs for its users, and carbon emissions. We've spoken to more than 15 people around the world. We're right now speaking to a petroleum refinery that is considering putting us as a pilot in their refinery. We've met someone in the ammonia field that is happy to connect us with over 500 factories around the world, and we've gotten a great response from chemical manufacturers as well. Key takeaways: reverse osmosis is not the only target. As we learned from our friend in the ammonia field, we can displace other technologies as well. Surprisingly large volumes are being treated, which is great for our business case, and we should really approach integrators so that they can put us in the hands of customers. Within 5 years, and just a 5% penetration of the beachhead market, taking into account the price of hydrogen, the price of electricity, and the concentration of pollutants, ParagonH2 could be making more than €12 million per year. On the environmental side, we're protecting bodies of water by making recycling of water cheaper, by creating new sources of water so that we can protect our bodies of water. In addition, on the climate side, a petroleum refinery using our technology instead of reverse osmosis could save 3,000 tons of carbon emissions per year. Not to mention that the entire beachhead market as a whole, if they use our technology instead of reverse osmosis, 2 million tons of carbon emissions could be prevented every year. We have a dream, and that's to use clean energy to supply the world with clean water and clean electricity. I teamed up with Matt after I saw the great work he was doing in the water treatment technology field. I myself come from business and engineering experience background around the world with more than 10 years of experience. Matthew is running a lab at the Technion and is invited to speak around the world on energy storage technologies and water treatment technologies. Our great mentor, Bern, has almost 2 decades of experience in the investment banking world and is situated in Europe. And we're currently speaking to 2 professionals to join us on the side of consulting for the business side as well as the water side. By 2025, we expect to have 75 customers around the world, to begin growing to desalination for cities, and within 10 years to team up with on-demand hydrogen users to create clean water and electricity for remote sites around the world. We are ParagonH2. We thank you very much.
Thank you very much, ParagonH2. Well done. Jury members, are you in? Looking forward to what you have to ask to our contestant there. Raise your hand if you have a question for Yes, Edward, please.
Yeah, you talked about...
Wait a second, sorry, Edward. I keep saying myself.
Thank you very much. hear me now?
Thank you very much, ParagonH2. Well done.
Oh, I'm sorry.
Jury members, are you in?
Just a second. There we go. All right. Hi, everybody. So I fixed it.
Hi, can you be able to hear me now?
Yes, perfect. Thanks a lot.
Yes, you talked about 75 customers, and I'm just curious, do you have an estimate where these customers will be coming from? Just ballpark, names of continents or countries.
Sure. I think that the probability is fairly high that it'll be in Europe and Asia. Currently, actually, just this morning, I had a very productive phone call with a petroleum refinery from Asia. So that brings us to about 3 different partners potentially piloting with us. 2 of them are in Israel, 1 of them is in Asia, and I think that the strong push for hydrogen in Europe is very promising. So Asia and Europe seems like a good place. Not to mention the fact that Japan is pushing very hard on hydrogen, and they expect a 50% reduction in hydrogen costs over the next 10 years. So that's also a very appealing market for us.
Thank you. Who's next? Jury members? Yes, Michelle?
Hi there. Thank you for this great presentation. I'm interested to know how the technology is applicable to domestic water supply, or indeed to local authorities providing domestic water sources.
I'm so sorry. It cut off a little bit. I'm not sure what exactly you said.
Domestic water supply. Does the technology apply to provision of domestic water?
Does it apply to domestic water supply is the question.
Definitely. So once you, long-term vision is desalination. So if you look at, for example, 7 years down the line, 5 years down the line, when we're starting to do desalination, you could set up a facility wherever it is you want to start desalinating water from the local supply, providing it to communities that need it in that area. And 10 years, this is very pessimistic, I think 10 years, but it could happen sooner, where we team up with companies that are making electrolyzers, that are using renewable energy from the sun, for example. So you can have on-demand hydrogen manufacturing, and then you can provide clean water through desalination and electricity to communities in different places around the world using their local supplies.
Thank you. Shloka, did I see you raise your hand as well?
Yes, thank you so much. This was a really interesting presentation. I think my question really had to do with a lot of the sort of desalination, the energy efficient desalination processes or innovations that I've seen in the past have had to do with sort of solar thermal processes. Is there a reason you decided to go with hydrogen, and could you just explain a little bit more about that?
And quickly, please. Time is running out. Thank you.
My co-founder is an expert in the area of energy storage and water treatment technologies. We've been working on this type of technology for at least 2 years, and hydrogen is a clean source to be putting next to the water that you're treating. So it's a very appropriate chemical energy source to provide for the desalination process. So you're not adding pollutants into the water while you're cleaning it. That's a strong driving force for using hydrogen in the vicinity of water.
Thank you very much, ParagonH2.